Welcome back, everybody. We're going to take a look at falling platforms today. Specifically, we're going to extend the kinematic base. If you haven't watched that video before, please go back and check that out so you can get an idea of where we're at. We're going to go to our kinematic base, and we're going to look at it real quick just to see in the event graph that the event activate is going to call the timeline, which is going to lerp between the start and end reference points by transforming the pivot of the mesh through those points. So with that, what we're going to do is take this kinematic base, and we're going to create a child blueprint class from it by right-click, create child blueprint, and we're just going to name it falling platforms, or falling platform, I guess. We're just making the one. So inside of this, we're going to modify the mesh to look more like a platform. I'm just going to give it a scale of 3.1. This will change the way it will look for us out in the world. And then we're going to change this so that rather than calling the function to manipulate the timeline, what we're going to do is have the player's interaction and contact with the mesh create the movement. So we're going to go over to the mesh in the details panel. Under collision, we're going to choose simulation generates hit events. This is going to allow the hit events to actually register so we can fire off the collision hit right here on component hit. We're going to choose the other actor, make sure it was the player. We're going to cast to the player, and then we're going to just call our activate to test our product so far. So if things are working, then this should mean that when the player jumps on the platform, it will do its timeline. So to test this, we're going to pull one out into the world and just make sure that we offset our endpoint. Otherwise, the platform will go nowhere. So let's drop the platform down here. Let's go to play in the editor. And then I drop down on the platform. Perfect. Things are working as expected. Going back into this, we're going to give a little bit more play context for the player, the conveyance of understanding that things are going to change around them. So we're going to add a timeline to shake the platform. So we're going to go add timeline. We'll call this shake timeline. And what we're going to do is we're going to try and control the rotation of the mesh over time. So I'm going to go ahead and grab the mesh reference out here, and we're going to set world rotation. And then we're going to look to create a value in the timeline that's going to allow us to control the rotation of this. So we're going to go into our shake timeline. Under track, you can see that we don't have a rotator option, but we do have a vector option, which is going to give us the values that we want. So I'm going to call this shake out rotation. So for this, we just want to create a really rough track here. I'm going to create a X value. I'm just going to shift click on these, and we only need really 1 second of timeline. And I'm going to take one up and one down. I suppose we can increase the magnitude of this a little bit. And I guess we don't need that middle one either. All right, so with this, we'll set it to auto, and then we'll go back to our Y values, and we'll do something similar. We'll do 1, 2, 3. There we go. So let's take a number of these up, and we'll take these ones down. And I guess we can add another point here, and there we go. We'll shake it back up so it's going up at the same time this one's expecting an up vector. Take this, set it to auto. Obviously the endpoints don't match up, but this is just for demonstrative purposes. So our timeline is now going to wobble back and forth, and that's really what we're looking for. This is going to produce a vector out, and we need to connect this to a rotator. If I set this up to fire off on update, which is what we want for our rotation, and I told it to just connect these two, it's going to generate a rotation from X vector, which is not going to produce the thing that we want. Obviously that is irregular and inappropriate. So what we're going to do is we're going to break our vector, and we're going to make a rotator. So when I do that, I can just take the X, Y values and link them up. The Z value we'll throw in there for good measure, even though we're not going to be using it. And this should get us the ability to see the platform shake. So you can see a little wobble there. Perfect. It's not very dramatic, but it is effective. And then after that, we're just going to go from finished, and we're going to fire our activate function. And that should get us a wobble and then a drop. All right, so we can already see that this is working out pretty well. We might want to reset our platforms afterwards. If you don't want to reset them, you can always create or you don't want to reset all of them, but some of them, you can create a branch and set up a Boolean to control that. But what we're going to do is we're going to have a slight delay. And then after that delay, what I'm going to do is I'm going to grab the movement timeline from the original kinematic base, and then I'm going to grab my shake timeline. And we're just going to set new time to 0 for both of those. And the delay that we're going to use should be at least as long as the period it takes for the platform to fall, but we're just going to give ourselves a little bit extra time. We're going to do a duration plus, and I'm going to promote this to a variable. We'll just call this reset delay. So when the player or designer decides how much time they want to add between this, we can take this reset delay, expose that out, and we'll just start by saying 2 seconds. So with this in place, you want to be mindful that the player can ride the platform down. So if you don't have this going through like a kill volume or something, you may want to adjust how far it goes out of scene, because the player will ride that right back up to the top. It will create possibly some dissonant behavior. So with this, we can set up a series of platforms that allows the player to traverse a space and then those platforms will reset so they can come back at a later time. Now, one thing you may have noticed with this is that these platforms are all the same height, and so this works out pretty well. I'm going to select all of these and switch to autoplay. When I simulate all this, you can see it there. They're going to drop at the same rate, which works out really well. You want things to behave similarly, but the problem is they're not actually behaving the same. They're just configured the same. So when we want this to demonstrate some varied behavior, maybe you have platforms that go over an increasingly large chasm and you don't need the platforms to fall so far. We want to observe that the difference here is that these are going to traverse the total speed or the total distance at the same time, so their speeds are going to be different. So to make this a little bit nicer, we probably want to control for this. First thing that we're going to want to do is I'm going to go into the base class and I'm going to set the curve for all of these from a linear curve to a parabolic curve. And this parabolic curve is just one that I created. It doesn't have to be an exact parabola, but the idea that classical mechanics are going to have us moving at a more parabolic rate. So if I preview this, it looks a little bit better because they start off slow and then accelerate, but as they get on, you can start to see the distance is going to become very apparent. Not as much of an issue if you have the player jumping from one to the other. They're not going to be able to check the rate of one compared to the time of another, but it may be something the players will notice that some of them fall really fast and some of them don't near the end of their cycle. So to link this up a little bit better, we're going to come back into our function here, and we're going to extend off of the begin play. We're going to set our duration, and so we're going to fix our duration set, and we're also going to get our movement timeline, and we're going to set rate again here. So the set play rate is going to be related to the same way that we had configured it for the parent class, where we do 1 over, and ideally this would be a function that you could call or design in the parent class that we would just override. But what we're going to set up here is just some classical mechanical physics where we're going to get the distance. We'll go from the start to the end. We'll get the world location for this. Oh, that's the wrong node. There we go. And we're going to get the world location for the end as well. And I'm just going to extend these out by splitting the structures. And we're going to take the z value, z start minus z end. And then from there, we're going to divide that by 1/2 gravity. So that should be 490, because gravity is 9.8 meters per second, so 980 centimeters per second divided by 2 gets us 490. With the 490 there, the other thing that we need to do is get the square root of this value. So SQRT is the node for that. And with the square root, then we want to set our duration. And this should get us a value that normalizes the playback rate and duration to reflect a more consistent fall rate. And so now they accelerate towards the bottom, and you can see that they're falling. If that's a little slow to start, you can of course parameterize this value, but if we I'll kick this up to something silly like 3. If we go back and we simulate this, you can see it can fall faster. Something in the 1.5 range might get you a little bit more gameplay intensity. And so if I select all these again and turn off autoplay, then I should be able to play, see those fall down. And of course, you could always add some fanfare to add some particle systems to this to get the player to see things spawn in with particle effects or sound effects or some sort of wavy entrance. But the hooks are all there. Hopefully this is informative on how to create falling platforms extending from our kinematic base. You definitely need to refine and enhance this system, but hopefully this lets you go out there and keep building.